Dear students, in the previous classes, we have discussed the meaning of and evolution of game theory and also the elements of game theory. In the present class, we discuss the concept of equilibrium used in the context of game theory. As you have already studied, in the economic theory of markets, perfect competition, monopoly, monopolistic competition, etc., the concept of equilibrium is used to describe a situation in which both the suppliers and demanders are content with the outcome. When the market is in equilibrium, neither the suppliers nor the demanders have any tendency to deviate. Stated differently, both the suppliers and the demanders are content with the market outcome. And given the equilibrium price and quantity, no participant has an incentive to deviate. Now the question is whether there is such a similar concept in game theory, whether such a similar concept exists in the context of game theory. Now the answer is, in the context of game theory involving strategic interaction between the firms, we develop a related concept of equilibrium which was initially developed in the 1950s by John Nash and is known as Nash equilibrium. In the previous class, we have discussed Nash equilibrium and equilibrium as it is defined in the conventional economic theory in an informal way. Now we give a formal definition of the concept of Nash equilibrium. And Nash equilibrium involves strategic choices that once made provide no incentive for the players to alter their behavior. Strategic choices once made provides no incentive for the players to alter their behavior. And it is, a Nash equilibrium is a strategy for each player that is the best choice for each player given the others' equilibrium strategies. A Nash equilibrium is a strategy for each player that is the best choice for each player given the others' equilibrium strategies. And Nash equilibrium can be defined by using the concept of best responses. The concept of best responses was defined in the context of Cournot model. Now we define the concept of best response in the language of game theory. Now, let me define what is a best response. In an n-player game, as we have defined earlier, the game may consist of 2, 3 or n players. Strategy SI. In an n-player game, strategy SI is the best response to rivals strategies S minus I, to rivals strategies S minus I if player I cannot obtain a higher payoff with any other possible strategy S dash I, which is an element of SI. If player SI cannot obtain a higher payoff with any other possible strategy S dash I, an element of the strategy set SI, given that the rivals are playing S minus I. This is the definition of best response. In an n-player game, the strategy SI is the best response to rivals strategies S minus I if player I cannot obtain a higher payoff by playing any other strategy S dash I, which is an element of the strategy set SI, as long as the rivals are playing the strategy S minus I. Let me define it once more. SI is, small letter SI is the best response for player I to its rival strategies S minus I. SI is the best strategy of player I to its rivals strategies S minus I, denoted by SI, an element of best response S minus I. I will define this. The strategy SI is the best response of player I to its rivals strategies S minus I, denoted by SI, the best response to the rival strategy S minus I if UI SI S minus I is greater than or equal to UI S dash I S minus I. UI SI S minus I greater than or equal to UI S dash I S minus I for all S dash I, an element of SI. Now, as we have defined earlier, each player has a strategy set. In a strategy set, it can adopt any strategy. For example, the strategy set may consist of charging different prices. Then SI, S dash I, etc. are different prices: low price, medium price, high price, etc. So the best response is SI is the best response for player I to its rival's strategy S minus I denoted as SI is the best response to its rival's strategy S minus I if UI is the payoff received by player I, given that the rival is playing the strategy S minus I, that is the payoff obtained from this strategy profile is greater than the payoff received by player I playing any other strategy S dash I, as long as the rivals are playing S minus I, where S dash I is an element of Si. Now, this is the definition of best response. We will explain these concepts with an example later. Now, a technicality embedded in the definition is that there may be a set of best responses rather than a unique one. There may be a set of best responses rather than a unique one. If the rival is playing S minus I, Si is one of the best responses of player I, one of the best responses. That is why Si is written as an element of the best responses. So, given that the rival is playing S minus I, there may be a set of best responses rather than a unique one. That is why we used set inclusion notation. Si, an element of the best responses of I, given that the rival or the rivals are playing S minus I. Now, suppose that and in this case, if I write this best response like this, there may be more than one best responses for player I to the strategies of the rival firms. And suppose that if there is only one best response, if there is only one best response, we can write it as Si is the best response of player I to the strategies S minus I. Si is the best response of I. There is no need for set inclusion notation. Si is the only best response. So we write Si as the best response of I to its rivals' strategies S minus I. Now, given this definition of best responses, we can define the concept of Nash equilibrium in an n-player game. Given this definition of best responses, we can define the concept of Nash equilibrium in an n-player game as follows. A Nash equilibrium is a strategy profile. A Nash equilibrium is a strategy profile S star 1, S star 2, etc., S star n. A Nash equilibrium is a strategy profile S star 1, S star 2, etc., S star n, such that for each player 1, 2, etc., n. For each player 1, 2, etc., n, S star I is for each player 1, 2, etc., n. S star I is the best response to the other players' equilibrium strategies. S star minus A. S star minus A. So a Nash equilibrium is a strategy profile S star 1, S star 2, etc., S star n, such that for each player 1 to n, S star I is the best response to the other players' equilibrium strategies S star I. That is, S star I is an element of the best response to the best response of the rivals' strategies. S star I, an element of the best response of player I to the best response strategies of S star minus I. S star I minus I means the strategies of all the players other than the ith player. So this is the definition of Nash equilibrium. A Nash equilibrium is a strategy profile such that for each player S star I is the best response to the other player's equilibrium strategies, and it is given by this equation. S star I is the best response, because there may be many best responses. That is why the set inclusion notation. Otherwise, we can simply write it as S star I is equal to, we simply write it as S star I is equal to the best response S star minus I. No, set inclusion notation. And this notation can be made simple if you consider a two-player game. Suppose that there are only two players, 1 and 2. Then the best responses are S star 1, S star 2. The best responses are S star 1 and S star 2. Now, in a two-player game, S star 1 and S star 2 is a Nash equilibrium if S star 1 and S star 2 are mutual best responses against each other. Mutual best responses against each other. U1, S star 1, S star 2 greater than or equal to U1, S1, S star for all S1 and element of S1. Then U2, S star 2, S star 1 greater than or equal to U2, S2, S star 1 for all S2 an element of S2. So in a two-player game, it is easy to define the Nash equilibrium like this. Payoff, this is the payoff of player 1 if both are adopting their best response strategies. It is greater than if player 1 is adopting S1 when the player 2 is adopting S star 2, the best response. And this S1 is an element of the strategy set S1. Similarly, this is the payoff of player 2, U2, and the payoff of player 2 is greater than or equal to the payoff obtained from playing the game such that the player 2 is using S2, an element of S2. So this is the definition of Nash equilibrium. So in a Nash equilibrium, we define equilibrium as a situation in which every player is adopting its best response. And what is the best response? The best response is the one which gives maximum payoff to the player given the strategies adopted by the rivals. And if all the players are adopting their best responses, that is adopting the strategies which maximizes their payoff, we call this Nash equilibrium. And if a Nash equilibrium is a stable equilibrium, in the sense that once Nash equilibrium is achieved, none of the firms will have an incentive to deviate. If the Nash equilibrium is reached, none of the firms will have a tendency to deviate. So Nash equilibrium is a stable equilibrium. For a stable equilibrium. And as it is clear, is if none of the firms have a tendency to deviate, it means that if any firm deviates from this strategy profile, then its payoff will decline. If the payoff of any firm increases, if it deviates from that particular strategy, then it is not a Nash equilibrium strategy. If the outcome is not a Nash equilibrium, then at least one firm will increase its payoff by deviating. So Nash equilibrium is stable. All the firms, once in Nash equilibrium, maximizes their payoffs. There is no tendency for any of the firm or any of the player to deviate. Now, this is the concept of Nash equilibrium. Now, let us see why the concept of Nash equilibrium is important. Now, one reason why the concept of Nash equilibrium is widely used in the context of strategic setting is that a Nash equilibrium is guaranteed for all the games. A Nash equilibrium is guaranteed for all the games. That we will see with examples. A Nash equilibrium is guaranteed for all the games. As we will see later, in pure strategies, there will not be a Nash equilibrium, but we can derive Nash equilibrium in mixed strategies. And pure strategies, mixed strategies, etc. will be considered later. So the reason why the concept is so popular is, in all games, a Nash equilibrium is guaranteed. And Nash equilibrium has two drawbacks. One is that there may be multiple Nash equilibrium. Multiple Nash equilibrium. That is one limitation of the concept of Nash equilibria. If there is multiple Nash equilibria, we cannot say which equilibria the players will reach. That is one limitation of the concept of Nash equilibrium. The second limitation is, what we say is that once a Nash equilibrium is reached, none of the players have any incentive to deviate. But game theory tells us nothing about how this equilibrium is actually achieved. How this equilibrium is actually attained. As we have seen in the Cournot model, Cournot equilibrium is stable, but Cournot model says nothing about how equilibrium is attained. That is a second limitation of game theory. One is, there is a possibility of multiple Nash equilibria. Second is, game theory cannot tell us how the Nash equilibrium is actually, because the players are moving simultaneously. We assume that each one is taking the best responses. If they are taking the best responses, simultaneously Nash equilibrium is reached and there is no tendency for any player to deviate. But what is the guarantee that they will simultaneously adopt the best responses and how the Nash equilibrium is actually established? Now, having defined the concept of Nash equilibria, in the next class we will explain the concept with an example.